Hello everyone, I am David W. Parker. This is Programming Today I Learned, WebGL series, episode 72. This is part 1. We're going to be looking at lighting finally. There's going to be a lot of math in this particular episode. I'm not going to go into the details and the linear algebra of it all, and I'm not going to explain where it comes from, but trust me, it works, and you can always go ahead to the Googles and DuckDuckGo and whatnot and find where these formulas are derived from if you really want to know more. And maybe one day I might go into them in detail, but today is not that day. So let's go ahead and get started. Let's just talk about lighting. So we got a couple of types of lighting that we're going to be looking at. One is lighting via diffuse reflection. The other is via ambient reflection. And so for the first episode here, we're just going to be looking at diffuse, and in the next and further episodes, we'll be looking at ambient, as well as both here. So the surface color by diffuse means the reflection differs by light position, meaning if the light comes in from an angle over here versus an angle over here, those are two different ways that the surface color will be reflecting that light. Ambient, on the other hand, means that the light reflection remains the same through any position. So this one, it takes into consideration the cosine of an angle for diffuse, versus the other one does not. So you're going to have the color of the light, which oftentimes may be 111, if it's such as the sun or something like that, times the base color of the surface times this cosine angle, which is the angle between the light and the surface. And so let's give a couple of examples of this and take a look at what the formula looks like. So if we have the light source as white, we're going to pretend it's like the sun. And of course you can use different tones of orange or something. Let's say you're driving and you have orange lights from overhead lights or something like that. We have a green object here, so this is the value of that. And the angle is perpendicular, meaning it's perfectly square with the at a 90-degree angle to the surface. So cosine of A will be 1 in this instance. We'll have 111, which is the light source, light color right here, times the color of the surface, 010 from the green, and then 111 right here for the cosine angle, which means we're going to have 010. Another one, let's say we have the angles at 60 degrees and everything else remains the same. Cosine of A is now 0.5. Filling in all of these in and replacing the 1s with the 0.5, you'll now see that the RGB is 0, 0.5, and 0. So we're going to have a slightly darker green, not as bright, when the angle is at an angle. Now normally you don't have that angle, so it's kind of hard to calculate, or not hard to calculate though. So the cosine angle is derived from the light direction with the dot product, which is a linear algebra expression, which we can go into another time, but not today, times the orientation of a surface. And the orientation of a surface means the surface normal, also a linear algebra term, of a surface. So if you take a square, for example, and just kind of watch my mouse outline here, if we have a square that is basically looks like this, we'll have two surface normals, one coming out of the surface towards us and one going out of the surface away from us. Note that the surface orientation vectors must all be of length 1, so we'll normalize them. And surface normals have two normals, front and back. So let's go ahead and let me just show you real quick. Here's a lighted cube. You could see we have the light sources coming from over here, and you could see it's darker over here and here. Surface normal for this particular surface will be this direction here, and there's a negative one that goes backwards behind it. Surface normal for the top of the cube is going to go straight up. Surface normal for this side will go straight out this way. Surface normal for the other side over here that way, and so forth. Each of these sides has two surface normals though. Just remember, always one out and then one in. So let's jump back and see what the code looks like. So we have a lot of things pretty much the same as before. Changed to the format of drawing our surfaces out like one of the previous episodes. So we're only going to have 3 per side now, as well as the normals. So the side, for each of the sides, we'll have the normals going out and the normals that are going back. So if you look at the front one, we're going to be going forward on the z-axis towards us, and the same thing with the back one, we're going to be going negative on the z-axis. So that would be, again, be here, and then for the back side going back that way, and so on and so forth. So you can look at each of these vectors and you can see which direction they're facing. And then, of course, our regular cube and our indices as before. We've updated the selection color to maintain the same as before, and it does not work, and I'll explain why momentarily as well, and we'll get around to fixing that in a later episode. And so as I scroll down, this is where the magic starts to happen. We are setting the U-light as well as the U-light direction. Each of those are provided, of course, in this initial state. We'll look at the Vertex Shader in just a moment. So we're going to set the U-light color as 111 as before. It is the color of the sun. We're going to go ahead and set the light direction, and it's going to be from this particular location, and we can move the light direction around, of course. We're going to normalize here, and instead of the Vertex Shader, for the light direction, because we don't need to normalize it for every vertex. That being said, this normalize function is provided by the GL matrix library, and GL shaders language have a lot of their own functionality as well for normalizing and dot product and whatnot too. So we're just going to have a new vector here given the light direction from here. We're going to normalize that, and then we're going to go ahead and set that into the U-light direction as well. We'll get back to why this doesn't work in just a moment, but let me go ahead and look at the Vertex Shader. So we have the color, the anormal position, as well as the U-light color and the U-light direction here. The position is the same as before. The vertex, the varying color that's going to be provided is different. We're going to take the normal in and go ahead and normalize that. Then we're going to go ahead and take the dot product of the U-light direction and the normal. Now, if you recall from our formula, this is the same thing as cosine of A, because we said we had to compute that. So here's the light direction dot the orientation of the surface being the normal. So we have the cosine A here. We're going to take the max of 0 or whatever that value is to find the dot product of the light. And then now we're going to go ahead and multiply, and this is a formula provided at the very beginning right here, where we have the source color, the base color, and then multiplied by the angle. So now we have the U-light color times the attribute color for RGB times the dot light. So that gives us the diffuse value as before, and then we're just going to convert that with the attributes alpha as well to be the color. And that is what provides us with this. Now you can see, like I said before, the pixel selection will not work. Let me show this off real quick. So basically what's happening is in our Vertex Shader, we have a lot of math that we didn't really use before. We are normalizing, we're using dot product, and basically changing the color which is being passed in. Before we weren't doing that. We were just setting it based off the color that was in, and we replaced that color. Now because we're doing all this extra math, even though we're going to draw and change it to the read state, we're still going to be converting it. So these values are never going to end up being equal to what they should be. So you can see even though we're passing in red with 255, we're always going to end up with a different value here. And this side has another value, and this side has another value, because that's the math that is happening here. Another issue that we'll have is, as you can see, the colors don't show up here right after rotation and moving around on things. So that's another thing that we'll look at in another future episode. If you like what you saw today, please subscribe, like this video, that'll help me a lot. Share on social media if you will. Go to ProgrammingTIL.com, sign up for my newsletter, and that's it. Have a great one.